Hello, peoples. I'm just going to go over question 7 here. And also, I'm going to go over Troughton's Law and the 3 questions that have Troughton's Law in it. Okay? So, question 7 is kind of the most complicated way that you can be given a thermal problem. Probably you're going to get a question like this on your test too. Okay? So, question 7 says, use this given reaction to find the absolute entropy for SO2Cl2. So that compound, you'll notice, is not in your appendix. So that is an unknown compound. But what we can do is if we can find the delta S standard for this entire reaction, that means we can actually solve for the unknown, which is the absolute entropy of this particular compound, SO2Cl2. Okay, so here's what we're going to do. The first place you start is by trying to solve for the variables that will get you to that delta S standard. Delta S standard, okay? So we know the main equation is delta G standard is equal to delta H standard, and I'm saying standard because these are all standard values, okay? T delta S standard. So if we can find this by first finding this and this, then using this, we can find the absolute entropy for SO2Cl2. So we're looking for the value for that. Okay, so the first thing to do is to find the delta H standard. So that's what I'm going to do first, okay? Step 1, solve for delta H standard. And I believe if they haven't given you the values, for SO2Cl2, they've given you the delta H of formation. It's negative 389.1 kilojoules. But the other ones for the SO2 and the Cl2, you can get that from the appendix. And you'll notice that this is Cl2 in its standard state form. So for Cl2, the delta H of formation is just going to be 0. Okay, so step 1, solve for delta H standard. This is literally just products minus reactants that I'm doing for this one. Okay, so you do, I'm not going to write the whole equation. I'll just do, I'm doing products minus reactants to find the delta H standard. So the products are SO2Cl2, and there's 1 mole of that. So that's going to be 1 mole times negative 389.1 kilojoules per mole, and minus the SO2 you can look up in the appendix of your textbook. That's going to be 1 mole times I think it's negative 296.9 is what I have kilojoules per mole. All right, so if I do products minus reactants here, I have negative 92.2 kilojoules as my delta H standard. So now I have just found this. So I'm just going to put a blue check here. So I found that. Okay. Now my next step is going to find my delta G standard. So this is SO2Cl2's delta H of formation, and this is SO2's delta H of formation. Cl2 is not there because of the fact that Cl2 is 0 for formation. Okay, that's going to be the same for the delta G. So I'm going to do products minus reactants. What is that? G. I'm going to do products minus reactants for delta G as well. So starting with the product, that's going to be 1 mole times the delta G formation for SO2Cl2 is given. That's going to be negative 313.8 kilojoules per mole minus 1 mole times the delta G of formation of SO2. You can look it up. That's going to be negative 300 0.37 kilojoules per mole, and that gave me the answer of negative 13.4 kilojoules. So delta G standard for this entire reaction is negative 13.4 kilojoules. Okay, so now I have, I'll put a green check here. I just solved this over here, and then the blue one is the delta H standard. Because I have those two components and I have a temperature, I can actually solve for this now. So delta G is negative 13.4 kilojoules. That's going to equal delta H, which is negative 92.2 kilojoules, minus, what's the temperature here? 25 degrees Celsius, is it? Do they give us a temperature? Yeah, so they don't give us, oh, also, they don't need to give us a temperature because of the fact these are all standard states. So standard state temperature is 25 degrees, which is going to be 298 Kelvin. Okay, so that's going to be 298 Kelvin, and I am looking for my unknown, which is delta S standard. Okay, so if you solve this out for delta S standard, which you can do, you should get a delta S that is delta S standard. Should probably use red to just keep the color code going. Delta S standard resolved to be negative 0.264 kilojoules per Kelvin, but we know that we can't leave that in Kelvin because it is entropy. So we have to turn that into joules per Kelvin. So that's going to be 264 joules per Kelvin. Okay, so delta S standard is now negative 264 joules per Kelvin. So look, we already have the delta S standard for this reaction. So now that I know the delta S standard for this reaction, part 4 is, so this was part 3. I'm actually going to switch colors. Part 4 is to find the absolute entropy for my SO2Cl 2, right? Yeah, SO2Cl2. So that's just going to be products minus reactants again, right? So this is products minus reactants. So this is going to be set up. See, I have delta S standard. So you know that when we earlier found products minus reactants, we were solving for delta H or delta G, but now I have delta S, but I don't have my product. So my product is unknown, okay? So this is going to be negative 264 joules per Kelvin equals X minus, so my product is unknown. Why is that minus like that? My product is unknown. X minus 1 mole times 248.5 joules per mole Kelvin. So remember, chlorine or any kind of compound in its standard temperature at 25 degrees, all entropy values are positive. The only time entropy values will be 0, because standard state for entropy is absolute 0, is at that temperature. Okay, so at 25 degrees, all degrees Celsius, or wherever standard state is for enthalpy and free energy, everything's going to be positive value. So chlorine is no longer 0. Chlorine actually has a value. Okay, so you have to look those values up on your appendix. Then I have 1 mole of my second reactant, so that's going to be 223 joules per mole Kelvin, and that will give me X, which is actually the standard molar entropy, or standard molar entropy for SO2Cl2. So that's going to be that. I got 208 joules per Kelvin. Okay, so that's how you solve for an unknown compound based on the values that are given to you. Okay, so this is something that you don't know, and in order to get that, you have to do all that work. So you had to solve for delta G standard, delta H standard. Then once you've had solved for those, you had to solve for delta S standard for this equation, this delta G equals delta H minus T delta S equation. Once you got the T delta once you got the delta S standard, you can now do, you can basically reverse um, your work and do like delta S standard goes to products minus reactants and the product is unknown, solve for the product. Okay, so that was question 7, peoples.